Somebody is asking, do the genetic factors mean that somebody will definitely develop PSC, or does it depend on the individual coming into contact with certain environmental factors? We've had a couple of questions around this area.
So I mean, I think that this obviously, yeah, it's something that's very confusing, isn't it? I think you have to think of genetic conditions as two sorts of genetic conditions. There's obviously the ones like cystic fibrosis, where there's one gene that causes the disease, and therefore the risk to your children can be very high, or to other family members, okay? And therefore, you know, the risk of passing it on is quite substantial. And those are what we call Mendelian genetics, okay? The other sort of genetics I've been talking about is where there are many genes that contribute to genetic risk. And each of those genetic areas that contribute to risk increase your risks ever so tiny, okay? And they probably all add together in an additive way to increase your risk. Now, what that means is that's a very different sort of inheritance to the one where there's just one dominant gene causing the disease, where there might be a 1 in 1/4 chance of passing it to your children, or a 1 in 2 chance, okay? So for example, and of course, PSC is a rare disease, you know, about 1 in 10,000 people have it. So we think that if you have it, there is about a sort of 8 to 11-fold increased risk in your family members. But that's not, if you think how rare it is to start with, that risk is only really tiny. So we wouldn't advocate screening for it in your family members, and we wouldn't certainly, you know, we don't advocate that. So I suppose what I'm trying to say is it's a very different sort of genetic disease, which is common of lots of different diseases that we look after now, particularly of the autoimmune diseases, and that there's many genes that are increasing your risk, but they're all really tiny. And the bottom line is we can't advocate you go checking your children or screening for it. But it's something we see in the clinic that, you know, often within a family, a big family, you know, you might have someone with PSC and you might have a cousin with IBD, but a lot of the time you don't. Okay, does that answer the question? I hope it does.
Yeah, that's great. Thank you, Simon.
And we got another one about genetics and environmental factors, which I thought was really interesting. And it's would we conclude for identical twins, it's the environmental and lifestyle factors that determine if one gets PSC and the other doesn't?
It's really, I mean, genetic, I mean, I too, you know, the bottom line is lots of studies looked at the rates of genetics in identical genetic twins. The bottom line is there is something in that for PSC. There isn't really good data on that, to be honest with you, like there is for other disorders. But even in a lot of autoimmune disorders, the genetic concordance is sometimes only 50–60%. So what that means is you're absolutely right. There's some massive environmental factors. Genetics is only part of the story, okay? And it's hard to quantify what that is using those traditional twin studies in PSC. But, you know, I too, probably like Palak, have twins in my clinic. One doesn't have it, you know, and their twin doesn't, and they have it and their twin doesn't. And equally, I've got twins that both have got it, and one's got mild disease and one's got very rapid disease. So there's a lot more to it than just simple genetics.
Do you have any sense of what these environmental factors could be?
Well, I mean, I think, you know, Palak's done a huge amount of work on the microbiome. I think that's going to be major one thing, what bacteria are in our gut. There's going to be clearly environmental toxins. You know, the cigarette smoking thing's fascinating. I don't know if we know what that is, Palak, or what we understand by that. That's telling us something. And also, you've got to remember, when you look at the genome, there isn't just your genes, but your genes are, if you like, modified by chemical groups that are added to them. So there's things called, so there's a thing called methylation. So if you take a gene, you can have chemical groups added to a gene that affect if that gene's expressed or not. So it's not just the letters, but it's also what's added to it. And probably a lot of these environmental factors are altering those chemical groups added to our genes that may determine whether we're making stuff or not making stuff. So, but I mean, I think my hunch is bacteria are important. I don't know what you think, Palak. And I think, you know, there are lots of, but I think these studies are really very difficult to do. You know, Newcastle's done some beautiful studies PBC, but I think they're very difficult to do. So, Palak, you got any thoughts or you want to add?
No, I mean, I agree. I mean, I couldn't agree more that it's very difficult to do these sorts of studies. But I know a couple of people who are who looks at twins of PSC, and just like Simon said, one twin has it, the other doesn't, and that sort of emphasises that genetics are responsible for about, say, 10%, maybe a little bit more, of why people develop PSC. There is a huge amount of what we call missing heritability, so a huge amount of other factors that do sort of beyond genetics that influence why you get PSC. And if you look across the world, that's reflective. Not all the countries where inflammatory bowel disease is going up, PSC going up, and similarly, those parts of the world where there's most PSC tend to be at the very north, the Scandinavian countries, north of England, compared to those countries that are equatorial or sort of or subequatorial. It's beyond that. And even when we look at migration studies and other autoimmune conditions, you start to see the greater impact of environment, gut bacteria, chemicals, beyond what your genetic makeup is. So genetics explains some of it, but sort of not so much compared to environmental risk factors.
Yeah, I mean, the other thing about the genetics, of course, is a lot of so remember I talked about these SNPs and these genetic changes in our genetic code, and a lot of the studies so far really identify common SNPs, i.e. things that are present in more than 1% of the population. There are these things called rare variants, which are very unique to families or are very low prevalence. They're not very common. And really, some of the new genetic sequencing that you can do will give you an opportunity to unearth some of these rarer genetic things which aren't borne out in some of these other studies that we've done to date. But of course, you know, we hope through UK-PSC we're going to have access to more genetic sequencing, and we'll be able to start to see how that little bit of genetics, whether it increases as we understand this missing hereditary ability a little bit further, as Palak's pointed out.